Question number 1.4. Explain the meaning of statement electric charge of a body is quantized. So let us go with the first one. So it is said that, see, let us assume I have one body. Let us assume here I have one object and I want to charge this body, right, just by transferring electron. So how much charge I can put on this body? How much charge I can put on this body? I can put either equal to E, then I can add one more electron, then I can add one more electron. That is, every time I am adding charge equal to electron, that is 1.6 10 raised to minus 19, then in the next case I am adding plus 1.6 into 10 raised to minus 19. So the charge on a body will always increase in multiples of E. So on a body here the charge is 3E. Maybe if I supply one more electron, right, then it becomes plus 1, so it becomes 4E. That is, the charge on a body always increases or decreases in the multiple of E. You cannot add fraction of electron, right? We are not talking about quarks, okay? Quarks, the protons and neutrons actually are made up of quarks, but they are never seen separately, means they are not fundamental, right? And that you will learn in higher classes. So for you now the fundamental particle is electron. Ready for a unit about charge. When we talk about charge, the fundamental particle is a electron, right? So here only the integral number or integers, the electron can be either 1 or 2 or 3. If you talk the number of electrons on a body, it always in the integers, it never be in fraction, right? So here only the integer or integral number of electrons can be transferred from one body to the another, and not in fraction. We cannot transfer electron in fractions. Hence a body can possess total charge only in the integral or integer multiple of fundamental unit charge. That is, the charge on a body will always Q equals to NE, where N is an integer, that is N is equals to either 1, 2, 3, 4. It can never be a decimal or a fraction. So where Q is the total charge on a body, N is the number of electrons, and E is the charge of one electron, right? So this is the quantization, right? Quantized, see, if we talk about quantization, the meaning of quantization is something exists in fixed numbers or fixed packets. Okay, I don't want to go into the depth because this is not a theory lecture, right? But once if I will make theory lecture, then in theory lecture we will discuss in detail. Now next one is a B part. In the B part, why can one ignore quantization of electric charge when dealing with macroscopic levels? That is, if we deal with large number of particles or at a very large level, then we can ignore quantization. That what it is asked here, why we can ignore. See, a very simple example. Let's say you are going to buy some let's say wheat flour, गेहूं का आटा लेने आप जा रहे हो, राइट? और गेहूं के आटे में से एक दाना गिर गया, एक छोटा सा तिनका गिर गया, क्या उससे कुछ फ़र्क पड़ता है? नहीं पड़ता है, राइट? क्योंकि जो दाना है उसके मुकाबले जो पूरा कंटेनर है गेहूं का वो बड़ा है, उसमें इतने दाने हैं कि आप एक दाने को इग्नोर कर सकते हो. बट इफ़ वी आर गोइंग टू बाय लेट्स से डायमंड्स, then a very small, and these diamonds are let's say very expensive, then if a very small part of let's say diamond, right, let's say you have 100 diamond, if one of the diamond fall off, then you will be in tragedy, right? So at that time we cannot ignore, right, a single diamond, right? But when we talk about wheat flour, गेहूं के आटे की बात करते हैं, तो वहाँ हम एक दाने को इग्नोर कर सकते हैं, उसका जो एक दाना है उसको इग्नोर कर सकते हैं. So at that time we are not interested in that a single term. So here also when we talk about charges at very large magnitude, let's say I'm talking about a charge of, let's say it's not very large, it's not very small, 1 microcoulomb. So 1 microcoulomb contain approximately 6.25, you can calculate this, Q equals to NE, make N as a subject. So 1 microcoulomb contains 6.25 into 10 raised to 12 electrons, right? That is nearly 10 raised to 13 electron. So 10 raised to 13 electron is a very large number. If one electron falls off that part, we can ignore, right? So the same thing is asked here, because the magnitude of electron or magnitude of charges used at macroscopic level, that is at a high level, at a large level, is very huge. Suppose if I talk about 1 coulomb, then 1 coulomb include 6.25 into 10 raised to 18 electron, which are very large numbers. So at this stage we can ignore if one or two electrons are not there in this counted electrons, right? So we can ignore. So because the magnitude of the charges used at macroscopic level is very large as compared to charge of 1 electron, we can ignore quantization, right? Now one more thing we can add into this, that is here you can see that I have added one point from the NCERT. in this respect, the grainy nature of the charges is lost and it appears to be continuous. That is, when we say how the charge on a body increases or decreases, so it increases or decreases in steps. If we talk about micro level, not macro level, micro, very small, let's say we talk about nano level, right, which is smaller than the micro level, then the charge on a body increases like this. That is, it is either E or 2E, 3E, 4E. But if we talk at very large level, right, then this appears continuous. Let me explain you with an example, right. Let's say this is what I am drawing like this. So what you see here, you see steps, right. But if I zoom out, let's say again, if we zoom out, if we zoom out, right, then it will appear like a straight line. The best example is, let's say there is a mountain, right. When you go out and you observe mountain, so you observe straight lines, but if you go very close, you will find that these are not straight lines, right. इसमें ये straight नहीं है, इसमें कहीं सारे गड्ढे हैं, right. So there are, you can see there is a valleys and mountains, small valleys and mountains, right. This is not a straight line. So at a very large distance you can see a straight line. So similarly, at a very large level or macroscopic, not micro, macroscopic level, the charge on a body appears not in steps, that is not in grainy natures, but it appears to be continuous like this mountain. Okay, so